In this project, we create a software to watermark arbitrary images. The way this works is the software takes an image, it uses an autoencoder to get a latent representation for that image, which is a vector that represents that image in some high dimensional space. Then it uses a secret key to perturb that vector slightly to get another vector, and then it uses the autoencoder's decoder to convert the perturbed latent representation back into an image. So because the latent representations were very close, the images are almost exactly the same. There is no perceptible difference in that image. And if you have the secret key, you can take a watermarked image and you can detect the presence of a watermark. Here is an example. So right now the autoencoder is working, perturbing the latent representation and converting the thing back to an image. And you can see the image looks very realistic. A high score represents the presence of a watermark and a low score represents the absence of a watermark. A recovered latent is when we take an image and check for the presence of watermark. You can see that the latent still has a high score, which means that the latent still retains the watermark after you convert the image back into a latent. And this works extremely fast. So we imagine that one can use the script to create an API, which can be used in social media companies to watermark things that people have uploaded. And we believe that this can be easily extended to audio and video content as well. The cool thing about this approach is that detecting the presence of a watermark in an image when you don't have the secret key is as hard as solving worst case lattice problems on which the security of post-quantum cryptography is based on. Therefore, we can be sure that the watermark cannot be detected by an adversary and it does not change the image by a lot.